Deployment and Scalability, Fast Search Server 2010 for SharePoint, Module 2, Plan to deploy Microsoft Fast Search Server 2010 for SharePoint.
At the end of this module, you'll be able to plan out the search solution, plan a farm topology, and describe the redundancy and scalability options available in Fast Search Server 2010 for SharePoint. The planning phase comprises of the following tasks. Plan and design for content collection. You need to consider which content repositories you want to index. The output of this planning phase will be a content volume estimate for additional performance capacity planning and requirements on which indexing connectors that shall be used. Performance and capacity planning. Consider factors that affect sizing and scaling, such as content volumes, freshness requirements, and features that may affect performance. The output of this planning phase will be the initial multiple server architecture for the system. Plan for search features. Define how the content will be indexed. This includes defining which crawl properties from the content repositories that will be defined as managed properties in the index schema, and define your relevancy strategy and to what extent you would have to use relevancy features in the index schema. Also define how users will be able to refine their queries, primarily related to the built-in refinement options that affect the dimensioning of the system. The output of this phase will be the draft of the index schema to be used in your deployment. Plan your administration team. Identify members of your Fast Search Server 2010 for SharePoint team and assign administrative roles as appropriate. Roles include central administration, site administration, and the search center site. Depending upon the size of your organization and your requirements for search, some members of your search team might be assigned more than one administrative role, or you might require only one administrator for your entire Fast Search Server 2010 for SharePoint deployment. When you deploy Fast Search Server 2010 for SharePoint in a multiple server configuration, you must provide credentials for certain user accounts. These accounts are required for installation, administration, and the operation of Fast Search Server 2010 for SharePoint and the associated database server. In a Microsoft SharePoint server farm, where Fast Search Server 2010 for SharePoint shall be deployed, you must install and configure the following applications and databases: Fast Search Server 2010 for SharePoint, the Fast Query SSA, the Fast Search Connector or Content SSA, and the SQL Server database. Plan and design for content collection. Before end users can use the search functionality in Fast Search Server 2010 for SharePoint, the content that they will run queries against must be first crawled. The term content refers to an item that can be crawled, such as a website, a Microsoft Office document, or an email message file. The result of successfully crawling content is that the individual files or pieces of content that you want to make available to search queries are accessed and read by the indexing connector. By crawling content, you create a set of crawl properties for those items. These crawl properties are mapped to managed properties that are stored in the search index, also known as the index. The indexing connectors do not change the files on the host server. The files on the host servers are only accessed and read. They are not modified. In some cases, the last access date on the files that have been crawled may be updated, as the indexing connectors read the content on the host server. This applies only to some servers that host certain content sources. Most content sources can be crawled using the integrated indexing connectors in SharePoint Server 2010. You use the SharePoint Server 2010 Central Administration for most configuration and operational tasks. In addition to integrated indexing connectors, Fast Search Server 2010 for SharePoint offers additional content indexing connectors for web, Lotus Notes, and database content. These indexing connectors are configured mainly by editing XML files and Windows PowerShell commandlets, and you can operate them using the command line. The Fast Search connector is the indexing connector used to crawl SharePoint content, file shares, and websites, Exchange public folders, custom repositories, and line of business content. This connector can be used in most standard crawling scenarios. You use the SharePoint Server 2010 Central Administration site for most configuration tasks and operations. These indexing connectors are set up by configuring a Content Search Service Application, or SSA. Among other things, this SSA enables communication with Fast Search Server 2010 for SharePoint backend. You need to configure one Content Search Service application per content collection, in which you specify the location of the content source or sources, the crawl schedule, and other information. There is a default content collection called SP. When you create additional content collection, you will also have to set up a new Content Search Service application to feed it. The Fast Search connector crawls SharePoint sites, websites, file shares containing content such as Microsoft Office documents, Exchange public folders, line of business data, for example, content from databases, custom repositories, access with a custom built-in connector, and documenting content. The Fast Search Server 2010 for SharePoint also offers additional indexing connectors that can be used in specific scenarios. These Fast Search Server 2010 for SharePoint indexing connectors are configured outside the Microsoft SharePoint Server Central Administration site. In most cases, configuration is done by editing XML files or by using Windows PowerShell commands. In most cases, configuration is done by editing XML files or by using Windows PowerShell commandlets. You can crawl different kinds of content by using different indexing connectors, depending upon the content source and type. The Fast Search Server 2010 for SharePoint installation includes the Fast Search connector, the Fast Search web crawler, and the Fast Search Server for 2010 for SharePoint indexing connectors for Lotus Notes, and the Fast Search Server 2010 for SharePoint indexing connector for JDBC. The table shown here sets out the differences in the configuration and operation of the different indexing connectors. Before you can crawl content with the Fast Search connector, you must first determine where the content is and what kind of server the content is hosted on. After this information is collected, you can create one or more content sources that are used to crawl the content. These content sources provide the following information to the Fast Search connector during the crawl: the type of content that you want to crawl, for example, a SharePoint site, a database, or a file share, the start address for which to start crawling, and the behavior to use when crawling. For example, how deep the crawl from the start address is going to go, or how many server hops to allow for. And finally, the crawling schedule. Fast Search Server 2010 for SharePoint uses different indexing connectors for different content sources. The choice of the indexing connector is influenced by the type of content you want to crawl, by personal preference, and by specific needs of your organization. Most content sources can be crawled using the various indexing connectors offered through the Microsoft SharePoint Server 2010. The collection of the indexing connectors is sometimes referred to as a Fast Search connector, even though technically it is not a separate indexing connector. The Fast Search connector is associated with one particular content source, and thus indexing connector, through a Content Search Service Application SSA. This SSA connects with Microsoft SharePoint Server 2010 front end with the Fast Search Server 2010 for SharePoint backend. In addition, by choosing to install the Fast Search Server 2010 for SharePoint, you have access to 3 Fast Search Server 2010 for SharePoint specific indexing connectors. These connectors can feed web, database, and Lotus Notes content into the index. This table provides an overview of the available indexing connectors and their recommended uses. The Fast Search web crawler is a highly customizable indexing connector used to crawl website content. The Fast Search web crawler is able to scale to large environments, for example, when your organization is crawling a large number of external websites. In addition, the Fast Search web crawler is able to crawl dynamic web content, such as websites containing JavaScript. The Fast Search web crawler gathers content from a set of defined websites, which can be internal or external. The configuration of the Fast Search web crawler is done by editing a copy of an XML file. You can operate the Fast Search web crawler through a number of command line tools. The Fast Search web crawler is typically a component within a Fast Search Server 2010 for SharePoint installation. Internally, the Fast Search web crawler is organized as a collection of processes and logical entities, which in most cases run on a single machine. When the number of websites or total number of pages to be crawled is large, the Fast Search web crawler can be scaled by distributing these processes across multiple hosts, which requires additional configuration. The Fast Search web crawler can crawl HTTP, HTTPS, and FTP content and supports NTLM version 1, digest, basic authentication, and form logon authentication. RSS scheduling is supported, and you can tag linked documents from the feed. You would only use the website indexing connector when you have a limited amount of websites to crawl without dynamic content. Otherwise, you should use the Fast Search web crawler. For database content, you have the BDC-based indexing connectors or the Fast Search DB connector. The Fast Search database connector is a specialized indexing connector that gathers content from database content sources. The indexing connector is configured using XML template. You can operate the connector by using the command line options from the jdbc-connector.bat file. After running the configured connector, you map crawl properties to manage properties in the SharePoint Server 2010 Central Administration site to enable and to customize search on the content gathered by the connector. The connector uses an SQL statement to run against a crawl database. This statement is entirely customizable. The Fast Search database connector uses a checksum-based change detection for incremental crawls if there is no update information available. The connector also supports timestamp-based change detection and change detection based upon update and deleted flags. Also, it is possible to indicate pre- and post-operation procedures that have to be done to the database before it's crawled, which can be an advantage in certain cases. For BDC-based indexing connectors, you should use it when you wish to enable changelog-based crawling. This can be realized by directly modifying the connector model file and creating a stored procedure in the database. The Fast Search Lotus Notes connector is a specialized indexing connector that consists of two parts, a user directory connector and a content connector. The content connector gathers content from a Lotus Notes content source. The user directory connector ensures that the end users can only see Lotus Notes content that they have access to. The user directory connector maps the Active Directory user directory with Lotus Notes user accounts and is closely integrated with Fast Search authorization. The connector is configured using two XML templates, one for the user directory connector and one for the content connector. You operate the connector by using the command line options from the Lotus Notes connector.bat and Lotus Notes security.bat files. After running the configured content connector, you map crawl properties to manage properties in the SharePoint Server 2010 Central Administration to enable and customize search on the content gathered by the connector. The connector fully supports Lotus Notes security, including roles, and can index Lotus Notes databases as attachments. There are additional prerequisites and configurations in order to be able to crawl Lotus Notes content with the Lotus Notes indexing connector. These are mainly related to Lotus Domino settings. To crawl certain content sources, for example, databases or web services, you need the SharePoint Server 2010 connector framework. This framework enables you to use the Business Connectivity Services BCS models to call external data sources. These models define the connection details and structure of the external content source you are planning to crawl. The BCS models are imported into the Business Connectivity Service. You will point to a model when setting up the line of business data type connection source. There are a number of pre-designed BCS models you can use for database content, web service, WCF, and .NET custom code. It is also possible to create your own custom BCS model. In addition, it is possible to create your own custom connector using the connector framework and the BCS model. To build on the SharePoint Server 2010 connector framework, you need to use either SharePoint Designer or Microsoft Visual Studio 2010, depending upon your specific requirements and goals. Most Fast Search Server 2010 for SharePoint systems include several content sources for searching, which may include both public documents and proprietary items. For example, you may have an internal human resource database that requires restricted access, or you may have a products database that is available for public consumption. When planning for item-level security, consider the following questions. What content will be indexed? Is the content public or proprietary? What organizational security policies must be implemented? What user and group permissions are required? And how does the item-level security affect the search experience? When source content is crawled and indexed, authorization information is added to each item's managed properties, the item's ACL or access control list, identifying users and groups that are granted or denied access to the item. Item ACLs help set up item-level security by tagging each item with access permissions. Make sure that the account that is used for crawling content has full read to the subset of all the content that should be indexed and searchable. As a consequence of this, any Fast Search Server 2010 for SharePoint admin can get to that content inside the index without having the crawl account password. Work with colleagues who play a role in the organization's security team to understand security policies that relate to your content databases. Planning for item-level security should be an important part of your content planning. As you consider which content sources will be crawled and indexed, consider the following. What are the sources of the content repositories? For example, Microsoft, Lotus Notes, external databases, etc. What repositories are public and which are proprietary, which include confidential items? And which users and groups have permissions to access content source? If you are not a subject matter expert, you should ask for help from content owners and administrators in your organization. Fundamentally, you need to ask these following questions. Is the content public? Is the content proprietary? Is there a subset of items that contain confidential content? Should item-level security be defined for access by specific users and groups? And can you map your users and groups in content databases without Windows users and groups? Content permissions control access to your sites and index content. For Microsoft content, you will use the SharePoint Server 2010 groups, which control membership and fine-grained permissions to help provide item-level security. Each content source should have a user store created to serve as a security gateway to the permissions on content in the different content sources. However, when you plan to index Microsoft content sources, you do not have to create a user store. By default, a claims user store is created and implemented for Microsoft content when you install Fast Search Server 2010 for SharePoint. The Fast Search Authorization FSA generates a user search security filter by accessing permissions in your user stores. When sharing data between web parts, to avoid the risk of disclosing information that users should not see in search results pages, we recommend that you do not use fine-grained permissions. Instead, set permissions only at the site or site collection level, and do not share data with web part that is contained by a page that has different permissions than any of the data being shared. A multiple server deployment is recommended for most production environments, except small deployments without any fault tolerance requirements. When performing a multiple server deployment, you first install Fast Search Server 2010 for SharePoint on all servers to be used in the deployment. After that, you deploy the different components to the servers based upon your selected topology. Plan for performance capacity. Hardware performance recommendations. For a node in Fast Search Server 2010 for SharePoint, the CPU should be a minimum of 2 quad-core 2 GHz processors with a minimum of 4 GB of RAM, and disk storage typically between 1 and 3 terabytes. This disk subsystem should be able to handle a high number of disk transactions per second. As a general guideline, you should plan for deploying one index column in your installation per 15 million index items. The basis for this general guideline is a mix of 70% SharePoint items and 30% documents from file shares indexed, where source document size is between 10 and 100 kilobytes. You can index substantially more items per column, but this is highly dependent upon your hardware configuration, size of the documents, and selected feature set. It is not recommended to add more items per columns unless you have performed a realistic benchmarking. When adding index columns, you should follow the topology recommendations outlined in the section Recommended Topologies. This means an index deployment plan for a maximum of 15 million documents would require one index column and typically a 2-node deployment. Some documents, such as PowerPoint presentations with lots of graphics, may be large in some source volume size but contain very little searchable content. In this case, the size of the searchable item may be very small, and you might want to plan for more items per column. Adding more columns to a running installation requires a re-indexing of all content in order to re-partition the indexing columns. Ensure that you plan for sufficient index column capacity from the start. A complete rebuild of a multi-column index may take several days. Dimensioning should take into account content retrieval. This means how fast the connector can feed new or updated content into the system, and processing and indexing. This means how efficient the system can process and index items. In Fast Search Server 2010 for SharePoint environment, crawling content is an operation that must be tuned to be able to catch changes in content as fast as possible. The Fast Search connector is based upon a content pull approach, where the length of each crawl cycle determines the average time to discover changed content that must be indexed. You must perform testing in your environment to determine how long it takes to crawl content by using a particular content source, and whether the throughput consumed by crawling this content interferes with targeted user response times. For Fast Search connector, you can change the number of concurrent requests that a connector generates when it crawls using a specified content source. The bigger the number of concurrent requests, the faster the crawl speed. What you want to achieve is that all changes in the content repositories result in a re-indexed document. As long as the connector is dimensioned to be able to catch all updates, the load on the item processing and indexing will not increase, even if you reduce the time that is required to crawl all content sources. In this case, the only effect of adding capacity to the fast search connector is a reduced indexing latency. The two main dimensioning parameters that affect the overall indexing latency in your deployment are item processing capacity and indexing capacity. Item processing capacity. The main item processing overhead is related to parsing of document formats and extracting searchable content and metadata. If your content consists of a complex document, such as large PDF or Word documents, the item processing may become a bottleneck in your installation. As indicated in the recommended topology section, you should deploy the item processing component to all servers in your deployment when possible. Indexing capacity. Fast Search Server 2010 for SharePoint uses an incremental indexing mechanism that ensures low indexing latency for new or updated content. However, there has to be a reasonable balance between total number of indexed items and the items update ratio. You should perform a basic benchmark using a 2-node deployment to get a rough indication of where the bottleneck is. If both nodes run steady on high CPU load, this may indicate that the item processing is the bottleneck. We recommend that you reduce the number of items per column if you want to reduce the indexing latency. This reduction will both increase the item processing capacity, each node contributes to the item processing, and reduce the re-indexing time, thus reducing the indexing latency. This table summarizes the performance effects of Fast Search Server 2010 for SharePoint search-related features. Values that are shown are to be regarded as a rule of thumb, as the effect of a single feature varies according to usage. There are also interdependencies between the features that are not covered in this table. For performance impact, H is for high, M is for medium, and L is for low. Where no letter is specified, the item has an insignificant effect on the corresponding resource. From the following table, we can see that shallow refiners have a high impact on query processing. Deep refiners have a high impact on RAM or query matching. Full text sorting has a high impact on RAM or query matching. And the complex queries using many terms has a high impact on disk space. Again, this is a continuation of the previous table. Summarizing the performance effect of Fast Search Server 2010 for SharePoint search-related features. Again, the highest impact here is for high stop word threshold. It has a high impact on query matching, query processing, and disk access. The term redundancy is often misinterpreted to be synonymous with availability. While these concepts are related, they are not the same. Redundancy refers to the use of multiple servers in a load-balanced environment for any of several purposes, such as to improve farm performance, to scale out to accommodate additional users, and to improve availability. Availability is a more specialized concept that refers to a multiple server environment that is designed to accept connections and to operate normally even when one or more of the servers in the farm are not operational. Therefore, availability implies redundancy, and additionally implies a failover mechanism and several other possible characteristics. A redundant system, however, might not be highly available. Fast Search Server 2010 for SharePoint supports scalable server farms for capacity, performance, and availability. Typically, capacity is the first consideration in determining the number of servers computers to start with. After factoring in performance, availability also plays a role in determining both the number of servers and the size or capacity of the server computers in the server farm. Fast Search Server 2010 for SharePoint provides enterprise search, which consists of the four main parts: the Fast Search Server 2010 for SharePoint farm, the Fast Query Search Service Application (SSA), and the Fast Content Search Service Application (SSA), and the SQL Server Database. A Fast Search Server 2010 for SharePoint farm must have access to a SQL Server host within the associated SharePoint server farm that is used for storing configuration information. The Fast Content Search Service Application is a search service application in a SharePoint server farm that enables retrieving of content for indexing content from repositories. This SSA represents the default indexing connector for your Fast Search Server 2010 for SharePoint deployment. The Fast Query Search Service Application. This is a search service application SSA in a SharePoint server farm that provides the web front end, server role, and hosts websites for users. The Fast Search Query SSA provides the web front end, server role, and hosts website for users. The SSA also provides the people search functionality and query integration SDK interface through a query web service and a programmatic query object model. You must deploy the Fast Search Query SSA on the associated SharePoint server farm and additional SharePoint server farms that shall have queries served from the Fast Search Server 2010 for SharePoint farm. You can scale the Query SSA for query redundancy and availability by adding additional front-end web servers and application servers within the Query SSA role defined. The Fast Search Content SSA enables retrieving of content for indexing from content repositories. This SSA represents the default indexing connector for your Fast Search Server 2010 for SharePoint deployment. You must deploy the Fast Content SSA on the associated SharePoint server farm and additional SharePoint server farms that Fast Search Server 2010 for SharePoint shall index content from. You can scale the Content SSA for feeding redundancy and availability by adding additional application servers with the Content SSA role as defined. The following components within a Fast Search Server 2010 for SharePoint farm support redundancy: the content distributor, item processing, web link analysis, web analyzer, the indexing dispatcher, indexing, query matching, query processing, and fast-specific indexing connectors. The choice of high availability strategy depends upon several factors related to requirements and budget. High availability for all parts of the system will in most cases require more servers than given by the actual performance requirements. You need to ask yourself if it is acceptable that the performance is decreased when an error occurs. You also need to consider, do you want to have high availability only for important parts of the system, such as the ability to serve queries even if the components and the feeding chain fails, but a full reindex is still acceptable in these cases? And you also need to ask yourself about what is the maximum acceptable time to rebuild the index to the same state after a non-recoverable error in the feeding chain. Query high availability. This is usually the most important factor in a search solution. You can select between the following options for indexer high availability. Deploy a backup indexer node on a separate server. This will achieve the best high availability in case of a non-recoverable error situation. On the primary indexer, an operator must reconfigure the backup indexer to become the new primary indexer. Search will be available during the period between the error situation and the reconfiguration, assuming you have deployed more than one search row. Feeding and indexing will stop during this period. However, the flow control protocol will ensure that no items are lost. The cost of this option is that you must deploy 2 index servers per column, and the backup indexer will have a performance effect on the query matching running on the server. You have the option to perform a full regular data backup, including the binary index. This ensures fast recovery, limited by the time that is required to copy the backup data, but may, in large installations, imply unacceptably large backups with corresponding long downtime during regular backups. The disadvantage of a backup restore-based solution for the index is that the data index after the last backup will no longer be searchable. The restore procedure ensures that the indexing connectors will only refeed content that was updated after the last backup. Note that the complete Fast Search Server 2010 for SharePoint file must be taken down during the time of a backup, in which case search will not be available. You also have the option to perform a full regular backup and exclude the binary index. This reduces the size of the backup size and time. However, the recovery time will be significantly longer, involving a full rebuild of the index. Because search may be available during this time period, this is frequently an attractive compromise between cost aspects and freshness requirements. In this module, you have learned to plan out the search solution, plan a farm topology, and describe the redundancy and scalability options available in Fast Search Server 2010 for SharePoint.